Hi, today we are going to be talking about transformations of the graph. We are going to look at the graph of the parent function f of x equals x squared, which is the square function. We call this a parent function because pretty much we're going to do a bunch of things to this function. We're going to add or subtract things to the input value or the x value. We're going to add or subtract things to the function value. And it's all gonna, and the graph is gonna pretty much be based on what it looks like originally without any manipulations. So in the red graph, we have the graph of f of x equals x squared. And then I'm gonna go ahead and do a second graph. I think it's turned on. Cool. I'm gonna animate this. Okay. So I told you a lie a few seconds ago. The graph of the parent function is given by the purple function, by the purple graph, and then the graph of the transformation is given by the red graph. Okay, the red graph is a function of the form f of x minus c. Okay, so now the question is, what happens to the graph when we change the value of c? Okay, so right now I have the value of c animating from -6 to +6. That makes my head dizzy, so let me go ahead and put a pause. Let me set it to c equals 0. Okay, so if c equals 0, x minus 0 is still x, so this is pretty much, we're back at the parent function, or f of x. Now the question is, I can see the animation side to side, but that's a little bit too fast for me, so let me manually move it. What would happen to the graph if c equals +1? Okay, so if c equals +1, I guess we shifted the graph 1 unit to the right. That's pretty nice. Let's shift it. Let's see what we get when we have c equals 2. If c equals 2, looks like the graph of the parent function f of x equals x squared shifted 2 units to the right. What if c equals +3? Cool. All right, and then you get the drift. But now I'm more interested in what happens when c is negative. So let's go back to the parent graph. Cool. So that is the graph of f of x equals x squared. Now, what would the graph look like if c equals -1? So we have x minus -1. And when c is -1, looks like the graph shifted 1 unit to the left. If c is -2, you guessed it, we shift the graph 2 units to the left, and so forth. Okay, so pretty much the moral of this story is this. We have the graph of some parent function f of x. In this case, we're looking at the graph of f of x equals x squared. Now, if we apply the transformation of f of x minus c, I want to point out, what is it that we're changing? Are we changing the input or the x, or are we changing the function value or the output? In this case, we are doing something to the x. So in this case, the value of x is changing. What we're going to get to in a bit is that horizontal shifts are given by the form x minus c. Alright, so we had just explored transformations of the graph of the form f of x minus c, and we had established that if we have something of this nature, then that is going to cause a horizontal shift. Okay, so when c was positive, when we had +1, +2, +3, the graph shifted so many units to the right. When c was negative, the graph shifted so many units to the left. Okay, so now I'm gonna give you 2 graphs. Right now you can only see one. Okay, so let me go ahead animate, so you can see that we have 2 graphs. Okay, so the graph of the purple function reads f of x, so that is the graph of our parent function, f of x equals x squared. And then the transformation of the graph represents f of x plus c. So that's the one that's in action right now. So then the question is, what is going on? So in this case, looks like the graph is shifting up and down. As you can see on my screen, on the word side, we have f of x plus c. but on the decimal side, we have f of x plus k. Well, that's due to I don't want to say limited technologies. This is like a really good program, but it's just I can't use the same variable. So it has f of x plus k. Let's just pretend it says f of x plus c. Okay. So now again, what do you notice about the transformation of the graph? When we were applying transformations of the form of the form f of x minus c, we had a horizontal shifting. We went side to side. But now that we have f of x plus c, we have vertical shift. Okay, so my eyes are tired. Let me go ahead and pause this and set it back to a 0. Okay, so in this case, I want to point out, going to the word side, what is going on. The first animation, we had f of x minus c. So what we were changing was the input value, or the x value. Now we are applying transformations of the form f of x plus c. So I want to point out, what is the difference? First time around, we were doing something with x, or the input value. Second time around, the input value is intact. There's nothing that we're changing. What we're changing is we're taking the function value and adding something to it. So what I want to point out is this: if we're doing something to the x, then we're gonna have a horizontal shift. But if we're adding something to the function value, then we're gonna have a vertical shift. So let's go ahead. What happens if we're trying to graph, say, f of x plus 1? So let me go ahead, put c equals 1. Again, we're pretending that k is c. So when c equals 1, we shifted 1 unit up. When c equals 2, as you guessed, we go up 2 units, and so forth. But what if c equals, well, let's go back to 0. Okay, so again, we're assuming this variable reads c. If c equals 0, okay, we're back at the parent function, f of x. Now, what if c equals negative 1? Okay, so we go down 1 unit. What if c equals negative 2? Cool, we go down 2 units, and so forth. So the moral of the story is, let's get all these crazy animations up and going. Okay, the moral of the story is this: if we are applying a transformation, no matter what parent graph we're looking at, whether it's the square function, the cubic function, square root function, absolute value function, cube root function, I think I got all 6, except the line or the identity. If we are applying transformations of the form f of x minus c, that is going to be a horizontal shift. If c is positive, we're going to pull so many units to the right. If c is negative, we're going to pull so many units to the left. Now, vertical shifts are given of the form f of x plus c. And again, this has nothing to do with which of the 6 parent functions we're dealing with, or basic functions. Again, it could be the square function, the one that we are exploring, or the cubic function, and so forth. But transformations of the graph of the form f of x plus c, that is gonna be a vertical shift. Okay, so if c is positive, we're gonna pull up so many units. If c is negative, we're gonna pull down so many units. Something that I want to point out for the horizontal shift, because this is something that was a little bit difficult for me to accept. Horizontal shifts are of the form x minus a number. So in terms to identify the value of c, the value of c is always the number that follows. Is always the number that follows the subtraction sign. And I think that's pretty much it. So that is my time for decimals. We're gonna go to my fun lecture notes. Awesome. And as promised, we are back to the lecture notes. So in decimals, we were looking at the graph of one of the parent functions, f of x equals x squared, and we looked at the transformation of the graph, what happens when we are applying a transformation of the form f of x minus c, and what happens when we are applying a transformation of the form f of x plus c. So if we have f of x minus c, again, well, what is changing is the value of x, or the input. And just to reiterate, it says if c is greater than 0, who puts these math symbols? So where do I have space? Nowhere. I'll make space. So if c is positive, then we are going to shift so many units to the right. However, if C is negative, then we're going to shift so many units to the left. Again, very important. Horizontal shifts are of the form x minus c, or x minus a number. C is the number that follows the subtraction sign. So if this throws you off, cover up the subtraction sign, and then that will make it easier to identify what's the value of C. Okay, for vertical shifts, once again, the x is intact, so we're not changing the x values or the side-to-side action. We are adding something to the function value, and the note says that if C is positive, then we are gonna shift up, and if C is negative, then we're gonna shift so many units down. Okay, so I think like we're about 8 or 9 minutes. So I try to keep these videos short because sometimes it's not possible to sit down for a long video for whatever reason. So we're gonna stop right here, and then on the next video we're gonna do some actual examples. We can't let the computer do all the heavy lifting. Thank you guys.